All right, welcome everybody. Welcome to those that we have online on Zoom and to those that we have in person here at HGA. This is the March meeting of the ASHRAE Wisconsin chapter in collaboration with the FIAS Wisconsin chapter. So just a reminder for all of our members, we do have our upcoming presidential visit on April 6th. And we're gonna run through just a brief little bit about ASHRAE. We don't always do this, but because we do have a collaboration here today, just wanted to go over a little bit about what ASHRAE does as a society. So ASHRAE's mission as a society is to serve humanity by enhancing the arts and sciences of heating, ventilation, refrigeration, and air conditioning. There are 53,000 members nationally. And the major advocacy work that we do is around ASHRAE research, and standards and codes are another big thing that ASHRAE does around the nation. And then locally here for our Wisconsin chapter, we have about 400 members. And the last announcement for our Wisconsin ASHRAE chapter is, there we go. We are looking for submissions for our annual technology awards. So our chapter tech awards are due April 8th. And you can see our website for more information on that, as well as we are looking for nominations for chapter leadership. So if you are interested or would like to nominate yourself or a colleague, please find more information on our website or reach out to one of the ASHRAE representatives here today. Now I'm going to turn it over to our FIAS representative to give a couple words about the FIAS Wisconsin chapter.
Thank you for the invitation to co-sponsor this event with ASHRAE, my favorite organization. I am the secretary of the local chapter of the Passive House Institute US Alliance, and we have our license to reach out to the public, to let the public know what the Passive House is all about, what this new construction standard is all about, and to try to enlist more professionals in the name of contractors, builders, HVAC contractors into the Passive House community. We so far have not had any face-to-face meetings. We're all Zoomed. And I think we're getting really tired of being Zoomed. And so we're beginning to think about having local events. One of the local events we're going to do is monthly meetings to talk about high-performing houses. And another local event will be a yearly meeting at the MREA conference in Custer, Wisconsin, which is also always a hoot. But if you want to join our monthly Zoom meetings, we should have a list where you can put down your name and your email, and we'll send out invitations to you. So that's it. Thank you. And I hope this goes well.
Hello, everybody. So today presenting will be Dr. Teresa Weston. She graduated with a bachelor's in chemical engineering at MIT. She worked 25 years at DuPont. So in the last 2 years, she started her own consultancy firm. She's really involved with ASHRAE, writing technical specifications and helping with the standards. So with that, we'll have her presenting today residential building efficiency. So I'll pass it off to Doctor.
Are we on? Okay. Oh, I can't see it though. Well, this is the presentation. Moving. Okay, this is the different view that I'm used to, because I'm used to the, yeah, it's okay. I can work with it. Okay, so as I said, I'm going to talk about pathway to high performance residential buildings, and I'm going to use essentially what I guess is a case history and standards development with this, the redevelopment of standard 90.2 2018 as a leadership standard. Now, for those of you who are Passive House Alliance members, it is not to the extent that the Passive House certification is. It's not as high performing as necessarily a Passive House, but it is a step along the way. And so I am a certified CPHC, certified Passive House consultant. Just became one recently. And I am working on an ASHRAE standard for a path building standard at ASHRAE, which is 227P. That's not been released publicly and the drafts are still within committee, so I can't necessarily share that, but that is built on the Passive House. So ASHRAE is working on standards that are more more aligned with Passive House. So I'm going to talk about this in general, and then I'll take questions about this. I'm also involved in the developments of the IECC, which is currently going through to develop the 2024. So I can answer questions about many of those things. They're not in the slides necessarily. But before we start, I'm part of the Distinguished Lecturer Program at ASHRAE, and there's just two basic slides. Obviously, there are evaluation forms. We'd like to see them. But the main thing about this slide is that the presentations are mine and my opinions, and they're not ASHRAE's opinions. So I do not speak for ASHRAE as a organization. I speak for myself, but I am sponsored by ASHRAE. So if you have any complaints with what I say, just make them to me. I'm perfectly happy to hear them and answer them. The other thing is ASHRAE, and I think you just had the chapter. Kathleen just went through some of the chapter items that are going on in this chapter, but ASHRAE really wants leadership, and on a national level, involvement in the technical committees and the society standards committees are really useful for people to have in. They always want new blood into these. There's a lot of us spend a lot of time in these committees looking at the same faces we've seen for the last 20 years. And it would be nice to see some new people come into them. So start at the chapter level if you don't want to travel to the national meetings or get involved in the national meetings. We are doing a lot of stuff still by Zoom, so you don't have to travel for them. So, okay, so getting on to what I'm going to talk today about. A brief introduction in where energy codes are standing. There's really only a brief introduction just to get us on the same basic playing field. And I'm going to talk about the development of 90.2 2018 and its transformation from the 2007 version, which was a little used standard that really didn't have a lot of value in the marketplace, standards marketplace. And the question was whether you kill it or whether you develop a better standard. And so we did work on developing it. And then I'll go through what is in 90.2 2018. And maybe I'll get some questions from you in terms of the comparison with Passive House, and I'll be able to hopefully answer those. And then the work that we're working on right now and where we're going with the 90.2 2018 standard, where the standards committee is working right now. So I think everybody knows that the background of building codes is trying to ameliorate climate change. We see that around, and we see it we see the result of climate change around every day. And I do some work in resilience as well. And So we need to look at the value of building resilient buildings as well as energy efficient buildings and melding those methods together. If you look at National Resources Defense Council and they look at pathway to this was from their document, the pathway to a safer climate future, you see that the blue bar there is there's a lot of it, a large portion of going to a safer climate future is related to energy efficiency. And then if you look at the US energy consumption by sector, and this is from 2020, you'll see residential is just under 25%. Okay, so that's residential, single family and multifamily. And so just under 25%, that's a lot of benefit we can get to ameliorate climate change and go to a more energy independent future for the country if we can reduce that. Now that is both new buildings and retrofit. 90.2 and the building codes are primarily new buildings. We know that we need to do some more retrofit work. And that is, and we also know it's a harder nut to crack. So we're starting with new buildings. I think we need to move, my personal opinion is we need to move to retrofit fairly quickly. And I think we also need to look at especially at-risk communities and look at senior housing and doing some specific things with senior housing. But that is not where the industry is right now. The industry is still trying to work with the new construction. These are the model energy codes over time. And these are based on the DOE evaluations of the codes and where they are versus, and everybody, well, you'll see that the 2006 code is used as a basis for a lot of them. And excuse me for the people on the phone, I'm gonna try to point things out. I don't think I have a pointer that I can use on the screen, so I'll just try to point out. So the federal government in the Energy Policy Act defined 90.1 as the federal minimum for commercial buildings. And at the time it was the Model Energy Code as the federal minimum standard for residential 1 and 2 family dwelling codes. That the MEC or the Model Energy Code has transformed into the International Energy Code residential section. 90.1 is still 90.1. And so the sort of bluish green pathway there, you see how the energy use index for 90.1 has changed over the years from 1980 down to the last one on here is the 2016, which went into the 2018 code. We have one more version. There's a 2019 90.1 that had not been evaluated when this chart was put together. And then the goldenrod line is the residential code. And since I'm mainly talking about residential codes in this thing, I'll talk a little bit more about that. This is the IECC. The last IECC was the 2021, and it dropped another 9.4% versus the 2018 code. So it's down maybe around where the just under where that blue-green line is below it. That's about where the 2021 is right now. But what you see is there's a plateau for a while, and then you get something that maybe you get a 10 or a 15% increase in efficiency or decrease in energy use, and then it plateaus for a while, and it goes down again, and then it plateaus for maybe a long while, and it goes down again. And you almost never in one cycle get more than 10 to 15% improvement. And that's moving, there's a general goal of net zero energy by 2030. The rate at which the energy code is moving is not going to get us there by itself. And so we need to have things that can be used as stretch codes. We call them stretch codes, we call them leadership codes, we call them advanced high performance standards. There's a lot of different terminology for them, but they're above code standards.
And we need probably a variety of them because every jurisdiction takes these model energy codes and then they adopt them. Now, I just learned just a few minutes ago that Wisconsin's on 2009, I think you said. 2009 is probably 20 or 30% below the 2021 energy code, which is still not going to, and the 2021 is still not going to get us to net zero energy housing by 2030. So it's really important that we look at stretch codes, adoption by localities. Cities can adopt a stretch code. It depends on how your state is worked out, what can be adopted. And so just speaking to groups like you is very important as we work through that. Now, IECC, which writes the IECC for both residential and commercial, has published their mission in a document called Leading the Way to Energy Efficiency. And they are looking at developing what they call glide paths to achieve zero energy buildings by 2030. And the way they work this out in their code, is it? I can't see what people are seeing, so. Yeah, I just, as long as everybody can see the slides, I'll work with it. I don't have too much that involves pointers, so. Zero energy by 2030. And the way they do that is they have a base code and then they have appendices that localities can adopt that have higher energy efficiency. They're more stringent than the base code, and they are written, and we'll see, and we got the first one that was aimed at getting buildings to net zero as an appendix in the 2021 code. And it's not perfect, and we've got some proposals to change it in there, but so the idea is they're trying to put this minimum code in that they can get agreed upon across the industry and get industry consensus on, which is very difficult. And then they have these additional proposals that overlay on it and fit well with there, and that's why they're written in that appendix form, but they're optional for adoption. So it can be a little complicated, but they are there. So I'm going to move to what we did with what ASHRAE did, and I was chairing the committee through a large part of this development with the 90.2. And as I said, the 2007 version of 90.2 was little used. I think it had 1 or 2 adoptions, but it wasn't really used. And it was, I don't think it was even almost at the minimum code level. It had basically been ignored for many years, for several years. And we got to the point where we had to figure out what was the purpose of having it there, because it wasn't being adopted. You had the IECC, that was the federal minimum for residential. What should we do with this? And so ASHRAE actually commissioned a standards advisory panel to look at what we would propose to do. And they put out a report within ASHRAE, but it's public, in November of 2011. And this gives you an idea of what the timeline it takes to develop one of these things. So if we're not working, and we're working on a passive building standard now, working on higher performance of things, we need to work on them now. We're only 8 years away from 2030, and we are not ready as an industry. ASHRAE is doing a great job from their part, but the industry isn't ready. And so the recommendations of that panel report and the base recommendations are written in this paragraph. It says at the low end, 90.2 could simply echo the IECC minimum energy efficiency levels. This is of questionable value and does not address the concern of lack of relevance of 90.2 in the industry. So we didn't want to just mimic what was in the IECC. At the high end, 90.2 could become a higher performance standard. Residential building similar to ASHRAE 189.1, which is what's in the International Green Construction Code. But they felt that that was maybe too broad, and in part due to organizations like DOE and NFPA to have a minimum energy code standard suitable for code adoption that was perceived as too far a stretch for 90.2 to be in the high performance. So therefore, it should be between those 2 degrees, and this entails an energy efficiency that is more stringent than IECC minimums, expanding the focus to include energy aspects, providing comfort and indoor environmental quality, and striving towards this 2030 timeframe for net zero or near net zero buildings. So the idea was that 90.2 was to become a stepping stone towards 2030 on energy only, but not address all of the green building issues that you find in LEED standards or in 189.1 for buildings. It wasn't going to become a 189.2. And these were the specific recommendations. They wanted it to be a standard that could be adopted internationally, an international leadership standard. They wanted the first baseline revision, the revision that we were working on, to be 50% improvement over the 2006 IECC baseline. And that was because at the time, 2006 baseline was what everybody was using as the baseline. It's what the ResNet 100 is based on, a 2006 IECC baseline. It doesn't mean anything other than you've got to pick a baseline. But they wanted 50% greater than that. So to cut the energy 50%. Address energy aspects related to indoor environmental quality, including comfort, moisture control, and indoor air quality. Should not address the broad subject of sustainability. So they wanted to keep it in the energy framework. Considered energy aspects of meeting residential water needs. So domestic hot water was not adequately in previous standards, was not adequately addressed in previous standards. Incorporate the requirements that use cost effectiveness as a significant criterion. So we did need to look at cost effectiveness. And this is where a lot of the rubber meets the road when you're trying to get changes to the energy code. So I'll talk a little bit more about that in detail later. Incorporate appropriate field performance metrics to measure compliance during construction. And this was to increase validation of what you designed was actually put on the building. So there's a verification section that is not present in the IECC and in some other standards. Easy to use and easy to enforce. And again, that's a judgment call. Evaluate energy use intensity as the energy criteria, and look at the inclusion of plug and process loads, and evaluate renewable energy alternatives as a part of the standard. So this was sort of the goals that were set out for the committee. It wasn't like you have to meet these or you won't be published. It was, these are the goals that we want you to evaluate as a committee, and they were presented. The committee started working on those and worked on them for basically 6 years to come up with, and went through multiple public reviews during those 6 years, dealt with greater than 200 public comments and on different sections of the code that you have to work through. This is not a quick process. It takes time. You learn a lot doing it though. So, we came out with a December 2018 publication. And I would say that the areas that were focused in the development that we wanted to include, that we focused on in there, was that it was a leadership standard. It was at that 50% greater than the baseline 2006 IECC, that it had flexibility that allowed ease of use and ease of adoption by location, and that it had been evaluated for being cost effective so that it could be implemented in the marketplace. So this is basically the table of contents of the 90.2. And you'll see that it has a short standard section, and then a lot of normative, which are required appendices, and then informative appendices, which explain how to use it. And the informative appendix include things like plan review inspection checklists, site inspection checklists. They're examples, but they basically show how you implement the standard. And they can be adapted by whatever the authority, the AHJ is, who's looking at using the standard. But there's a lot of things in there, and it's through some of the informative appendices, and I'll talk a little bit more about some of the later ones, that we get some of that ease of use and the ability to actually incorporate this at a jurisdictional level, which is where you need to make the difference. One change to the title, purpose, and scope of 90.2 was that no longer was manufactured housing exempted. It was supposed to be 1 and 2 family houses, low-rise residential, except manufactured housing. And with the changes in our building sites with modular as well as manufactured housing and people coming in, we looked at the standard, we looked at what we were doing, and there was no reason not to exempt manufactured housing. You know, physics doesn't know whether you're made in a factory versus whether you're built on a site. They just know where the materials are and where they come together. And although there are material differences and logistical differences, and there's definitely and I think this was the main reason they were exempted, there's definitely a code process difference because manufactured housing, a large part of them are regulated through housing and urban development. And actually 90.2 is being considered right now to be included in the next manufactured housing code because they have a separate code. They're not governed by the same building code, but there's no reason why the standard as it's built needs to not be used on manufactured housing. Okay, so getting to what's in the meat of the standard. Basically, it's a performance standard. It's based on an ERI pathway, Energy Rating Index pathway, which is very similar to a HERS rating index pathway. There's an ERI path starting in the 2015 code. It does do a version of an energy rating pathway. There are some prescriptive backstops and requirements overlaid on that ERI pathway, but these are only basically to guide that you're not making, when you have an energy rating index pathway and you just have one number, there are trade-offs you can make, and we want to guide people into making smart trade-offs. And that's what those are in there. There is a section on verification, a whole chapter on verification. And then in the informative appendix, this was one way that we viewed that there was increased flexibility were put into the standard, was we have procedures for generated prescriptive paths and an example prescriptive path. And the idea with putting in the procedures for generating prescriptive paths is that a jurisdiction or a company or an industry could make a prescriptive path. They could generate that based on the procedure that was in the informative appendix to make sure that it met the performance requirements. And then they could use the standard using that prescriptive path or one of these 10 prescriptive paths. You could have however many prescriptive paths you wanted. And prescriptive paths, particularly for small contractors, small builders, are the way people want to build houses. But if you put just a prescriptive path as your basic path, you are basically tying yourself to traditional ways of doing things and hurting the ability to develop new materials, new products, new assemblies, new ways of building. So we wanted to put prescriptive paths, a way of making sure that you get a prescriptive path that sort of was pre-tested to the performance path to allow that ease of using that prescription, but also make sure that it was connected. So we put in that link to there, and we viewed that as a way of extending the flexibility and the use to new materials. So specifically, it is at a level, it does have numbers that are at a level that are 50% more than the 2006 IECC. And I'll show you some of the validation we did on that. It is based on an energy rating index, which is the ASHRAE Resident ICC Standard 301. And these were the addenda that were in there. We've updated this to, you always have to update your reference standards, but when it first came out, this is what it was based on. There are some modifications to the rule set in the ERI. Most of them are lighting, related to the lighting provisions, because the lighting provisions in 90.2, we went with a higher level of lighting provisions, lighting efficiency. It was more aligned with Title 24 in California, which was advanced. No, it's actually, I'll show you the actual, it's a number, it's like a HERS rating. There was an energy rating index put in to the 2015 IECC. It was revised upwards. It actually got lowered. The efficiency levels actually got lowered in 2018. And then in 2021, they sort of went back to where they were in 2015. The numbers in 90.2 are basically the same that are in the IEC appendix on pathway to net zero buildings. So they are in the low to mid 40s. I think they need to be lowered again. I think we've moved on enough. You're always sort of behind where the industry is going. I think we can reach a lower number. That hasn't been proposed yet. So the numbers are significantly lower than what is in the IECC. So it's a lower, and you can get there. And I'll talk a little bit about the renewable energy portion of this later. So I said there were some overlay prescriptive requirements and backstops. There are minimum building insulation and air leakage performance. There's verification of installation and of insulation and verified air leakage, and there's a number of reference standards to do that in there. So not only do you have a backstop, you can't below a certain level, and you still even though you can in the ERI calculations, you could have, so that we put in some minimum backstops, but you also have to verify that what you put into the building is what you designed in the building to get the ERI pathway. And that is not, the level of verification is well above what is in the IECC. For mechanical systems, again, it's mainly about verification with duct testing, mandated duct testing, sizing and verification of the duct system performance, and requirements for design, installation, commissioning, verification, including duct air leakage, and all duct work is within conditioned space. You are allowed to do, there is an allowance to do buried ducts in the attics, which can be controversial as to whether those are really in the conditioned space. And there's an informative appendix on designing ducts in conditioned space and how you do that along with potentially with buried ducts. But the idea is that you want a ductwork in conditioned area. You do not want ductwork running through an unconditioned attic. There is plumbing system design in required. The idea is to minimize the water in the water that is kept in the plumbing system. I know this is part of Passive House as well. And again, verification that what you've put in has actually happened. So the difference between a certification program and the basic energy code is there's quite often there isn't verification other than or a plan review that goes on with energy code. Indoor environmental quality, we addressed slightly. We did not change any of the, we basically referenced other ASHRAE standards for comfort and for indoor environmental quality. We have a lighting section. And the idea was to have those, you need to meet those standards and then include however you met those standards, you need to include that energy in your ERI rating. So we didn't necessarily plow new ground on what you need to do for indoor environmental quality, but did address adding that into the energy budget of the house. Lighting systems, again, it was very much built on what work that had been done with Title 24 in California, revised modeling rules, credits for vacancy sensors, dimmers, and other control devices, and revised lighting allowances for all of the residential end uses. And it does go to high efficiency lighting systems and controls. And finally, you are allowed to reduce your ERI score based on using on-site power. Now, when you go to the net zero energy appendix, which has the same numbers of ERI score as 90.2, you have to get to those numbers without using on-site power. So for the straight 90.2, you can use on-site power to get there. If you were using 90.2 to meet that appendix, you would have to meet those numbers without using on-site power and then add on-site power onto that index. So I'm going to talk a little bit more. I'm going to try to get through this on what we did on cost, on how we have evaluated cost effectiveness, which was done a little bit differently than the IEC does, and talk a little bit about the ease of use and easy to enforce aspect of it, and what decisions we made based on that criteria. So first of all, cost effectiveness was based on the philosophy that you want to be the most cost effective you can be at this, you want the most energy savings you can be while still being cost effective. So we used a life cycle cost with a 30-year life cycle cost analysis. We used a particular economic and energy price and energy multipliers in the calculations. And it was based on a whole home life cycle cost analysis that included all of the provisions. When cost effectiveness is evaluated for code changes, generally it's by measure. So if you change an insulation level, you have to show that that is cost effective, not that the whole building is cost effective. And so we view that these things play off each other. And so it's better to look at what is this doing to the whole home in terms of the cost effectiveness. And we targeted a savings investment ratio of 1 to 1.1. So the way that works is, so the lowest cost solution is where that green triangle is. But what you're comparing, the baseline that you're comparing against is where the red circle is. So what you weren't trying to get to the lowest cost, you were trying to get to the most energy efficiency that doesn't take your cost over the 100% line, over where that red circle is. So where we were aiming is sort of the blue diamond, which gave you more cost effectiveness. It gave you more energy efficiency without increasing the cost, but we're not looking at minimizing the cost overall. And we're doing it based on the whole house. And that is a different aspect than is sometimes used in some of the cost effectiveness statements that are provided to energy codes. And everything you do with a change in an energy code has to be validated with cost effectiveness if it's to, say, the IECC. So we evaluated two options. We evaluated a design with using NACA minimum heating and cooling hot water equipment that included on-site power production. And then we looked at using higher efficiency equipment without on-site power. Both of these had higher building envelope components added to them. Both options both options had building envelopes that exceeded some of the 2015 IECC requirements. And we wanted to get energy cost savings 50% over the 90.2 reference design. And these are where we came out with those, and then the proposed numbers came out of sort of a average of the two pathways that we analyzed. And this paper that's written down at the bottom has the details of all of the cost effectiveness evaluations and savings. If you wanted to look into that more, I can provide that to anybody who wants the link or the reference. On easy to enforce, that was part of the reason we chose to go with the ERI pathway. The ERI pathway is in the IECC, and there is a compliance specialist description between HERS and IECC that basically allows HERS raters to be sort of supplemental energy inspectors for using that ERI pathway. Why is this important? Now, well, if you look at, and this is a survey, the survey that was done by a combination of National Institute of Building Science and ICC on the code officials, you find that there's going to be a tremendous, and this was done in 2014, and at that time, there was a huge number of code officials that were planning on retiring in 5 years. They probably already retired. We have a shortage of code officials. We've got budget considerations at a lot of local municipalities and jurisdictions. They're not hiring new code officials. They're overworked. And the thing that gets left out a lot of the times is specialist in energy in terms of inspections. And so having a pathway that can be inspected and verified by an existing workforce is really important in terms of the ease of enforcement and the ability to enforce a code. So as we think about, as I said, at ASHRAE, there's a pass for the people from Passive Building Alliance. There's a passive buildings standard looking at going through ASHRAE. As we look at that, getting the Passive House Alliance involved in how you can get involved with code officials and doing inspections with them or helping them out, making their ability to inspect that house easier because you've got a Passive House rater or a Passive House involved in that. I think that's something that you need to look at because the ability for jurisdictions to inspect on energy codes is at a crisis level. There just aren't enough people who are trained to do it. And so bringing in, and I suspect the ICC would do more of these MOUs to get these cross-industry specialists to do these inspections. So in conclusion, in terms of the development, we met all of the recommendations, at least to some extent. I did mention energy use intensity as the method we should evaluate. We did evaluate it. We did not use EUI numbers specifically to evaluate, primarily because the ERI was more able to be enforced in the industry, and that was the consideration. But we did evaluate it. But we met all of the standards, maybe not them all 100%, but we went at least 80% on all of the recommendations that came out of the panel in there. And I just want to look at where the committee is going now. We have put in a proposal to the current code cycle to replace currently in this net zero energy residential building provision. They just have the table with the ERI pathway, but they don't have of the other benefits that 90.2 provides in terms of verification and being a turnkey on how to manage that ERI pathway. So we've made a proposal to replace just the table with using 90.2 in that to strengthen the appendix for net zero buildings. It would still be based on achieving those numbers without on-site power and then adding on-site power to them to get to net zero energy. I don't, this is probably going to come up in about a month. We don't know where it's going to go on the committee. I think it's maybe got a 60-40 chance of going through, but I'm just ballparking it. We have updated the references, added some new references. We've added some clarification around some of the language in lighting, which was not as clear as we would have liked, particularly around common areas and multifamily, low-rise multifamily. So one of the other things that we're doing is and this is out for public review. It's actually out for public review for another 5 days. So if you're a member of ASHRAE, or even not, if you can get on the public review and write comments on the changes, we'd appreciate hearing them. We really want to get industry feedback on this. We're looking at extending 90.2 to all residential buildings, to look at not just low-rise residential, but to have a common stretch code for all residential, for multifamily dwellings as well. And there are some complications. There's some complications that you can see in the IECCs right now, because they're between two codes. When you go from 3 stories to 4 stories, you change code, you change requirements, you change how you do air leakage testing. It's very complicated. So we'd like to put it all in one document. That makes it more difficult. We're going to have to do some revisions on how we treat some things in there. But 301, which is our underlying ERI score, has already moved to being able to evaluate dwelling units as well as in multifamily buildings, as well as single family buildings. So we'd like to move to it. And also, there's some other things to specifically cover renewable energy systems more directly in the standard. And we also want to get to connected or algorithmic control. So connected thermostats, smart thermostats, putting those into there, and the energy efficiency benefits you can get from there. So that is out for another 5 days for public comment. I looked at it about 3 days ago, and we already had 30 public comments. Usually you get at least 2/3 of your public comments in the last week. So I'm thinking we're going to have probably in the 90 to 100 public comments on what we proposed. Some of them are positive, and some of them are, we don't like what you're doing, we should change the number, everybody's confused by it. You know, there's a whole lot of different comments coming in. The committee really wants to get feedback on how we do this. We do want to go to have all residential occupancy under the same banner, under the same standard, but we need to make sure that we're doing it in a way that supports the overall community. So I'll just close, and they talked about this being a leadership standard, and just summarizing what a leadership standard is, it's on the pathway to net zero energy. It includes the energy aspects of indoor environmental quality related plug loads, on-site energy, and it has to also address implementation in terms of the benefit, cost, the validation, and ease of adoption. And so with that, I just want to acknowledge SSPC 90.2, which is the committee that I worked with and chaired for 4 years, the past and current chairs of SS 90.2, and the ASHRAE Residential Building Committee, who were the people who sponsored me to put together a presentation on 90.2. And I appreciate their support. So with that, I'll take any questions. Hopefully this has been somewhat informative or maybe enlightening on how complicated the code and standards process is. And I'll just open it to questions. I'll do in the room or online. I don't know. Do we have?
This is Vijay Mehta.
Okay.
I have a question on you. ASHRAE intend to achieve net zero by 2030. What is the current rate of energy usage?
Sorry, we're getting some.
So if we are going to achieve net zero by 2030, is it like 50% or below, or what at present?
I'm having trouble hearing him.
Okay.
It's still net zero, and that's
No,
8 years away and a
what I'm saying-
big push. I don't know if we need to accelerate we need to accelerate on that pathway if we're going to make it. But the stated goal of all of the for new buildings is net zero by 2030. And I have my doubts on whether we will do it at the current, unless we we'll put
Do
some pedal to
you
the metal
achieve
on doing
net zero by generating, say, like putting PVC panels or generating your own electricity at site or what?
Rule of thumb, you do about 70% of it with equipment, building envelope first, equipment and hot water, et cetera. Then do about 70% of that. And you don't want to do more than the last 30% based on on-site power, solar, or I guess you could do on-site wind or through some sort of purchase contact to on-site renewable.
And can you please put a PowerPoint to everybody to share it for your presentation today?
I'm gonna provide a PDF.
Okay,
I'll do it after and do a follow-up with that.
thank you.
Yeah. Mhm. So they need. Mhm. That's okay. Would you like to say it louder in the microphone?
I can't hear it, anything.
I'll paraphrase. So she's giving an example of a Wisconsin climate house, because it does vary by climate zone on how easy it is, saying that she was going to passive house and net zero. I think you said it was a 3-story, 3,500 square foot house, which is quite large. And they put 60 PV panels. I don't know what the total power out of that 60 PV panels were, and they still did not make net zero. And so that we're in serious trouble. Yes, I think the 2030 goal is going to be very, very difficult unless we start looking at some really new technologies and put in place. But you can't do it all with on-site power. Don't expect solar panels to be your salvation on net zero in 2030. You've got to do, like I said, I think about 70% with the building itself. Mm-hmm. And I will say the net zero 2030 is for new buildings. It's not for existing buildings. And there's a lot more existing buildings out there. Mm-hmm. No, I mean, the addenda is saying you need to be in the mid 40s before solar. And there have been a lot of houses built to that level. But it takes care and it takes. No, it's that plus insulation and a number and windows, good windows. Mm-hmm. Yeah, so guessing to sum up what your comment is, we really need to look at new pathways and not just hope that slapping a lot of PV on the buildings of roofs is going to get us there. And so the question was about the percentage of selling back to the energy companies versus storage on site. And I don't have numbers on that for you. I'm sorry. It's out of what I work in personally. But I think the net metering is it's by jurisdiction. So I think we need to get to some net metering. Yeah. Yeah. So there is a benefit to the on-site energy storage. I mean, there's some issues with fire with on-site storage that they're working with on codes on how to, where you put the battery storage. And there's been some documentation of unfortunate placement, I guess, that has caused some fires. But there is a benefit for that in terms of energy security during resilience and during an event. If right now, a lot of people have gas generators, if you can replace that with energy storage, if you have a power outage, a lot of people cannot take a power outage if they're at-risk community, if they're an at-risk community, if they have health problems there, they need to have refrigeration on site. If you have a passive house, you can get through a power outage in terms of the temperature of the inside for a lot longer. You can go maybe 4 or 5 days versus 1 day with depending on the weather outside, with loss of power and losing either heat or air conditioning if you have a passive house. But if you have a poorly insulated house, you're going to need that backup. So I think the backup power situation does help for resilience and security, power security in an outage. Yeah, and I mean, so, and I guess, there's also, you have to also get the transportation part of that into it, and whether you're doing charging electric vehicles and essentially using your car as a storage. There's a lot of questions about how we go forward with this, and they set up 2030 as the goal 10 plus years ago, and the goal date hasn't changed, but we haven't advanced along the curve to achieve it as quickly.
I just had one question. This is Vijay. California state has a mandate, any new houses have to be net zero. How do they achieve that?
Well, for one thing, California has a really good climate to achieve it in.
Correct. Solar.
I mean, realistically, California does have very stringent rules on lighting, they're very stringent rules in their code, and they have a lot of prescriptive codes, compliance pathways. But one of the benefits that California Title 24 does is that a large part of the state just doesn't need as much HVAC conditioning of buildings. I grew up in Southern California. In a house that it was an old house, had been built, well, it was built in the 40s. So it was, old at the time, and I'm old, so it's really old now. It did not have air conditioning. I grew up without air conditioning in, and we, open the windows in the evening, let it cool off, because there was a large diurnal temperature drop, and you could cool off and then shade it during the hot part of the day. We had trees around the house. We were in a canyon. And the house stayed pretty comfortable, actually. In the winter, we had just small gas. We didn't have ducted heat. We had gas space heaters, which maybe not real safe around kids because they were like open flames low to the ground, but we didn't burn ourselves up and we made it through. And we weren't particularly uncomfortable during the winter either. So you could use, I mean, I'm not saying that's where we should go, but California has the benefit of having a good climate condition. You couldn't get by with that sort of condition in Wisconsin.
Thank you.
On the speed, maybe 2035 for the cold climate zones. Yeah. And we do have a climate zone based code, but it's not, we're not speeding it up fast enough for the whole thing. Just getting the standard written is the most proud. The biggest, I think that the biggest hurdle was trying to get to a number that we felt was efficient enough to make a large step forward, but still being able to be cost effective. The cost effectiveness numbers are really hard to, the cost effective analysis is not easy. You have to base things on the current prices of technology. And so you don't get into new technologies and that learning curve cost reduction. That's not included in any of the cost effectiveness. So it's sort of always backwards looking, and it's really hard to get balance those and get those through. So I wish we had gone down lower and more effectiveness, but more energy efficiency, but we couldn't get there with the cost effectiveness metrics that we were using. And they don't include the learning curve. And and we don't know the learning curve on a lot of these materials. And I think that's a really important thing when we need to include the learning curve of cost reduction through learning curve. Yes, so the question was about implementation on the codes on the local level and the lack of trained or certified workforce to do that. And I would go back to that survey that says we're losing code officials, and a lot of the guys that we're losing are the people who really knew building and had been there a long time. And I think that where you're going to have to go in is you're going to have to get groups like ResNet, HERS raters, passive house raters, who know how to look for the key areas and do verification. We also need more verification and checklists, which is why we put them in. Now they're informative. You don't have to use them, but they're at least suggested. The idea is to get the verification rules out there and to find where you can do cross-training that already exists that can be fit with the compliance requirements in those codes and standards. Because you're not going to be developing a new workforce. You're not going to be doing full training. So you got to use what's out there and try to mix those together. Okay, I think I'm 4 minutes over. Oh,
I'm gonna close it out.
okay. And then you've got my other one already on there, so.
Yep, perfect.
There he is, Gus.
Hey, VJ.
Hey, VJ, I don't know who you are, but you ask good questions.
Yeah.
Thank you.
Milwaukee County.
Oh,
Yeah.
I can close it, right?
Oh, I was gonna say a couple things. So just to close out, everybody, please don't forget to fill out your DL evaluation forms. Please sign in if you haven't. The ASHRAE Tech Awards will be coming up, so take a look at the website. We're looking for submissions. Please submit on those. Next meeting will be April 15th. We'll have a presidential visit. That'll be at MSOE, so keep an eye out for information on that. And thanks everybody for attending. Thank you to Dr. Weston. She came here and to the Madison chapter, so thank you for volunteering your time to ASHRAE. Appreciate it. Thank you, everybody.